Good day, ladies and gentlemen. This is Banner's Online Maths. Let's see what we have on the board. Okay, we are asked to determine the differential equation which has the function y equals to a plus bx all multiplied by an exponential function e to the power x plus c e to the power minus x as its general solution. Okay, let's start by saying solution. Given the equation y equals to a plus bx all multiplied by e to the power x plus c e to the power minus x. Okay, we're asked to determine the differential equation. If you watch this, you find out that this is not a differential equation. This equation is not a differential equation because there is no differential coefficient found there. And what do I mean by differential coefficient? The y, the x, or y prime. So these are called differential coefficients. So it's not found here. But we're asked to make it to be a differential equation. How do we do that? In fact, this is what we call formation of differential equation. We're asked to form a differential equation using this. First of all, you ask yourself, how many constants do we have here? We have two constants. What are they? We have three constants. What are they? A, B, and C. And since we have three constants, we're expected to differentiate 3 good times. If we have only one constant, we are to differentiate once. If there are two constants, you differentiate twice. If there are three constants, you differentiate 3 good times or thrice. As a matter of fact, in the given equation, we have 3 constants which are A, B, and C. As a matter of fact, we are going to differentiate up to 3 times. Okay, if we call this, of course, let's open this bracket first. That becomes that y is equals to, remember this an exponential function outside the bracket will multiply the 2 terms inside this bracket. If we do that, that becomes this into this will give us a e to the power x. This plus is this. This into this will give us b e to the power x. We give us bx e to the power x. Then plus c e to the power minus x. Let's call this equation 1. So we're going to have our first derivative. We're going to differentiate y with respect to x here. If we do that, we're going to have y prime will be equals to, that's the first derivative, will be, of course, if we differentiate the first term, how many terms do we have here? 1, 2, 3. So we're going to differentiate term by term. Now, coming to the first term, we have a e to the power x. Now, differentiate this. Remember, a is a constant. Bring it out. A is a constant. The derivative has to be on an exponential function, e to the power x. And from the standard derivative, we are told that if we differentiate e to the power x, we are going to still have the same thing. To still give us the same thing, e to the power x. As a matter of fact, if we differentiate this, we are going to have the same thing, e to the power x. Now, for the second term, plus, coming here, this is the second term, we have b, x e to the power x. Remember, b is a constant, bring it out. b is a constant, the derivative has to be on x e to power x. X e to power x. We have to differentiate x e to power x. So if we differentiate x e to power x, let me bring it out. Let's bring it out. We have x e to power x. Of course, the first function is a product is x. The second one is an exponential function. So we have product of the same function. This is a function of x. This is also a function of x. So we apply product rule. Product rule states that you leave the first function, which is x, and differentiate the second function, which is e to power x, with respect to x. Then plus, you leave the second function, which is e to power x, and differentiate the first function, which is x, with respect to x. If we do that, we're going to have this to be, this x, nothing is affecting x, bring it down, we have x. Then this means differentiate e to power x with respect to x. Remember, once you differentiate it, an exponential function, it doesn't change. So we're going to have this to be e to power x. Then this plus is this. Nothing is affecting this. Bring it down, e to power x. Then differentiate x. We're going to have 1. So we're going to have this to be x e to power x plus e to power x times 1 will give us e to power x. So, which simply means that if we differentiate x e to power x, we are going to have that, which is x e to power x plus e. So here we're going to have x e to power x plus e to power x. That's what we have. Then the last term is this term plus. Differentiate c e to power minus x. Of course, c is a constant. Look at it. So the derivative has to be on e to power minus x. If we bring it out, look up. Look at this. E to power minus x. Look at it here. E to power minus x. If you are asked to differentiate e to power minus ax, its derivative becomes minus a e to power minus ax. Therefore, this is invisible 1, which means e to power minus 1. So if you're asked to differentiate this, we are going to have minus e to power minus x. Take note. So this is going to give us the derivative of e to power minus x is going to give us minus e to power minus x. If we simplify further,